What if the real reason most breakthrough technologies never changed the world isn't the science, but that nobody did the hard work of proving it was a business before they built a company around it? Welcome to Industry Ignited, the podcast where we explore the leaders driving transformation across industry, manufacturing, and innovation. I'm your host, Dr. Leanne Aguilar, and today I'm joined by George Boyajian, CEO of Muscle Polymers, a leader in technology company creation and growth with more than 30 years of experience sourcing, de-risking, acquiring, and launching science-based ventures. George, welcome to the show.
Thank you, Leanne. It's nice to be here.
Well, I'm excited to learn all about your business and innovation. I know we had a pre-call and I learned all about the many different possibilities and uses, and many that are still to be discovered with your polymer. And so let's dive in. Now, let's start with your background. You said that your core obsession since childhood has been getting university research out into society because the current system is wildly inefficient. Where did that mission come from, and what did you see early on that made you determined to fix it?
I grew up during the Apollo era, which was sort of a heyday of technology development. And during my lifetime, we went from slide rules to handheld calculators to PCs to cloud computing. A lot of that came out of universities, a lot of that came out of the military, a lot of that came out of industry. But as I watching the space program and watching what came out of that, whether it be ballpoint pens or Tang or whatever other things came out of that. And then once I got to the university and saw the billions of dollars that were going into research in universities, and it was pure research. Not a lot of it was coming out in products. You could see that. And there was the ivory tower piece of it. When I got into the university, people wanted to publish, but they weren't particularly interested in getting stuff out. That was the late 70s, early 80s. Tech transfer really wasn't a thing yet. There weren't many technology transfer programs, essentially none. And as I got into the academy, got my PhD, I just saw how there was this real disconnect between what happened behind the ivy covered walls and what happened with people having products that would help them. So that was really pushing me. And I saw it from the inside the academy and decided to get out and try and make it a little bit better.
Now, your path is unusual and compelling. Academic roots, then building first-of-a-kind ventures like a genetically engineered tree for environmental detox, followed by a university incubator role at Columbia. What did those early first ups teach you about what works and what absolutely breaks when science meets commercialization?
Oh, that's a good question. So, and I started my first company in 95 after I left Penn. There wasn't entrepreneurism was sort of just beginning. There were really not many things as incubators. Those were just starting. There weren't tech transfer offices. So I think some of the first things I learned was I was working with a bunch of Harvard MBAs, and they just drilled business into me. They basically said, the technology's good, but you really have to understand finance. You really need to understand accounting, IP law. So I took every single short course I could find. I read a bunch of Harvard Business School case studies. I read the Wall Street Journal every day, every article for 3 years, 2 or 3 years, and just completely soaked myself in business. I knew what it took to be the best in the world, a very narrow area when I got my PhD. And I figured I need to put in at least that much work to become a good business person. And, you can't do that in 2 years. I got better, but I didn't get great. So I think the first thing is most academics who are going to start businesses just don't know enough about business. They think they're smart, which they are, and they think they're the best in the world, but they're not the best in the world at the business. They may be the best in the world with their technology. So I think there's a certain naivete and arrogance combination that goes on. It's become less through time. I've been doing this for 30 years. In the beginning, it was rampant. Today, it's less so, but it's still out. So I think that's one of the biggest ones. The other big problem to get, on commercialization is people really just don't examine what it takes to be a business. Generally when I talk to entrepreneurs, they talk about all the technical hurdles. They talk about first viable product and things like that. And now I say, I'll give you all that, In fact, you can do it faster and cheaper. Now tell me what starts from there, right? And what they can't articulate is how their business will scale. Now I have a very narrow, my business model is build a company and sell it, not build a company and operate it as a lifestyle company from the rest of your career. My business model is get other people's money, put your own money in, get other people's money, and get them a return on your investment and exit and go do another one. It's not for everybody. Some people want to start companies and just run them for the rest of their lives, and that's a different model than generally
Mm,
I'm focusing on.
yeah.
So yeah,
I think you make some really good points, though, as far as people getting into business and knowing their trade really well, knowing how to do the thing or make the thing, or knowing the technology, like you said, or especially if it's an academic, like a PhD, knowing their area of expertise really well. But running a business is a completely different animal. And I relate to that and feel like I did things backwards and later went back and got my MBA, later went back and, did my PhD in business because I was fascinated and curious. But running a business is its own thing, and not only that, but leading people, right? It's the leadership component,
and
and
and,
then
and
yeah,
yeah,
uh-huh.
I think the other part of it is running a tech business, and my focus is making things and getting them to market. Taking a technology and getting it to market, and realizing that you're actually going to end up running three entirely different businesses, and you might not be the right one. One is a R&D. It's a science project that becomes an R&D project, and then you make your first prototypes, and then you make it at scale and you operate a business. Those are three
Mm,
or four entirely different skill sets.
right,
Now, and it's not that you have to learn how to do one well. You have to learn to do all four well. That's all going to happen over 4 or 5 years if you expect to stay with the company. But I don't think people really appreciate all the stages you go through and all the different skill sets and how
right.
that evolves.
Yeah. No, that's a good point, and I think especially, um, 30 years ago, let's say, there was the access to resources and information on how to create a business and what makes it sustainable wasn't as accessible or available as it is today. So I think today with the internet and AI and virtual courses, it's easier to find out the information, but you still have to know that, yeah, there are those different parts of the business that you have to learn and know
Right. And,
and
and
consider.
now, yeah, and now you have so many more people who've been through this. I can hire
Hmm.
people that have built and exited companies and put them on my team. So now I've got a whole cadre of people that can be part of the team and help me along get to the next level. 30 years ago, that wasn't a case. And you shouldn't delve in the past. It's the old man telling, oh, back in the day. Today it's very different. But I still don't think people really understand that as well as they might for making things as
Right.
opposed to software. The evolution of the business skill set you need and how you need to switch out your team over the
Hmm.
course of years. But when you're doing software, it's a little different.
Right. But you also made another good point, which is knowing your exit plan, knowing your business model before getting started. It's like, are you building a business to position it to sell, or are you going to run this business long term and then eventually, pass it on to the next generation? Or, what's your exit strategy? So creating that solid business model from the beginning, I think is super important as well. So you have direction and an end goal in mind. And a lot of business owners don't put that in place from the beginning.
Yeah, we say work backwards.
Yeah.
Start with the exit and
Hmm.
work backwards. So when we started, Muscle Polymers not too long ago, we went through a long process of picking the right technology to start a business with. And one of the things we did in that process was we went to people or companies that we would sell our company to in 5 to 7 years. We went to CEOs, CFOs, heads of strategic planning, and said, if we have a company that looks like this and has this product portfolio, would you be interested in buying that? And then they have 5 and 7 year strategic plans. These big
Hmm.
companies certainly do. And they might, well, we're really pivoting in this direction or this direction. This is the way we see the industry going. And then we could adjust accordingly if we needed
Mm,
to. And we
smart.
stay in
Yeah.
touch with them. So, You don't want to build for something that the industry has no interest in,
Mhm.
or you want to at least be sensitive to that. So when you have forks in the road, which path do we go on? Oh, this one is more likely to get us to an exit.
Right.
You have that information. And if people are saying, oh, yeah, we have no interest in that, or they tell you about a technology that's going to supersede your technology or go in an entirely different direction and obviate what you think is going to be a successful company, well, then you know to drop that. Drop
Right.
that.
Oh, that's smart. That's a good strategy from the start. Go and interview those that you might want to buy you someday and
And I'll
figure
give
out
you,
what they're looking for.
I'll give you another example is when we had a really cool technology out of Princeton that provided an endpoint for kidney dialysis, and there was no clinical endpoint for kidney dialysis, and that was very valuable to companies like DaVita and Fresenius, these dialysis clinics. And we were behind the scenes trying to find out what the FDA was doing on endpoints for dialysis because we
Hmm.
knew we had to, or Medicare or Medicaid were doing for endpoints for dialysis. And people knew that. And we were about to launch the company. And somebody said, oh, you got to get on this call with the FDA, I think it was, or Medicaid. And as it turns out, they had come up over the last few years, they had secret working groups coming up with a different endpoint for dialysis. And our company was poof. The need for it was gone the
Oh,
next
wow.
day. And we were ready to launch. It wasn't gonna be announced for another 6 or 9 months, and we had deals with DaVita and Fresenius to
Mhm.
move forward, and that was that. That it was written in stone. It was going to be announced. We're going to draft all the rules, and it was a
Right.
different endpoint. Had we not been looking actively, we would have raised money. We would have
Hmm.
had this technology with no outcome.
Oh,
With
wow.
no
Wasted all
endpoint.
that time, money, effort. Right. Yeah. No, that's a good example. Now, George, you built and exited a medical device company that used motion sensors to detect health issues early. What did that experience teach you about designing technology around a clear clinical outcome and a buyer with urgency?
So I think we were solving a problem there was a need out there. If you have older parents living at home alone, they could have the I've fallen and I can't get up button, which only works about 25% of the time because half the time they fall, they won't press it. And
Mm,
half of that time they can't press it. And they won't press it because they think it makes them look helpless and then they'll get moved out of their house. Very strange. Yeah. So
psychological, right, reasons.
psychological.
Yeah.
So you've got a technology that everybody uses, but is only 25% effective, and that's the dirty secret that nobody in the industry talks about. So we were trying to solve that problem. What it taught us was don't listen to the medical community, all right, or the doctors. And to this day, there's a lot of emphasis on measuring vital signs as an indicator of health. Well, let me tell you something. By the time your vital signs change, you're probably sick in bed. You're lying on the floor. Your body can maintain homeostasis really well, even when you're super sick. You want to get it well before you're lying on the floor.
Right.
So what we're looking at is functional health, and we went to gerontologists and nurses to find out what constituted functional health. And it was activities of daily living. It had nothing to do with vital signs. So we tried to measure the things that mattered for elders living at home alone. Do you get out of bed? Can you dress yourself? Can you use the bathroom? Can you shower? Are you taking your meds? And we could do that all with motion sensors.
Hmm.
And while the medical community didn't necessarily go, oh, great, the assisted living facilities and people with parents at homes and gerontologists loved it because it was what they were measuring. That's what my parents are now 98, 94, and that's what we worry about. Are they getting out of the bed? Can they move around? They're not falling down in the bathroom. Are they taking their meds? If they're doing that, that's going to tell you whether or not they're doing well or not.
Hmm. Right.
Not not their blood pressure, not their pulse rate, not their breath. None of that really matters because if all that looks good and they can't get out of bed in the morning, well, it doesn't matter.
Right.
Yeah.
Yeah, so it's really about identifying the KPIs, really. These are
Right.
the measurable, outcomes that are the most important.
It was the voice of the customers. Going out there was talking to the elders. It was talking to the people that ran the assisted living facilities. It was going out there and constantly refining the product so it gave them what they needed. So it's
Hmm.
constant iteration with the clients. That's really what it came down to. And then we were also using state of the art technology. We used the first sort of mesh network, the Zigbee network out of TI. It was the first commercial application of that technology. We actually had to debug that stack, getting data out of the house before everybody had broadband. We actually had pulse styling out of the house. We came up with some really clever hardware. So it was a hardware software solution, completely integrated. What we were doing was building to solve a problem. We weren't taking a technology and finding something that it would solve. It wasn't we had a hammer and we were looking for a nail,
Yeah,
right? We had a
right.
nail and we were trying to design the best hammer for that.
Yeah. Well, and I think that's the best way to go. It's starting with the problem because then you know if it's useful and you actually arrive at a solution and it's needed as well. I think doing it the other way, you don't know if you even have a commercially viable product if the problem isn't there, right?
Right, right.
Now, you've navigated major inflection points, market crashes, pivots, and regulatory shifts that can kill a business overnight. How did those experiences shape your risk lens and your discipline around business viability versus cool technology?
Yeah, okay. Well, I think it's more of the discipline of running the business. Shepherd your cash very carefully. When you have an opportunity to raise cash, go get it and get more of it. Keep an eye on the markets. What you realize is no matter how well your business is running, no matter how good your product is, when the tide goes out, all the ships are stranded. If you're going to need capital and the markets crash, it doesn't matter how good you are, there will be no cash. It all dries up.
Right.
Investors are, I love investors and they're herd animals. And when then one goes running, they all go running. And then, you've got a minimum, 12 to 18 month cycle and sometimes 2 year cycle before the money comes back. So it's about really hiring smart with people that can do a lot of different things, keeping your cash burn low, having a little bit in reserve at all times. I fortunately haven't ever had to lay people off until I closed a company. So, there's the, get rich slow and get rich quick. There are very few things. A lot of people are focused on, software that scales really fast. And I get that, but there are not a lot of those out there. And when you're making products, you're going to be, 5, 7, 8 years before you really get to an exit. And you've just got to be patient. You got to, do the right things, do the fundamentals, make sure your technology is bulletproof, and you can keep your burn low during that interval. When you have an opportunity to get a deal closed, do it fast. Something might be coming down the road. Crazies might fly planes into buildings,
Yeah.
over leverage, real estate that has nothing to do with you, and that will destroy your business.
Right.
So you have to have enough to weather the storm, which you generally don't have the luxury to, but you have to move quickly. The only advantage little companies have over big companies is the ability to move quickly
Hmm.
and make decisions quickly. And when you have an opportunity to get a deal done, close an investor, don't wait. Just get it done, because tomorrow that person might be gone. That deal
Right.
might be gone.
Yeah, no, you make some really good points, and yeah, I think that's interesting that investors they're pack animals, like you're saying.
Yeah, I mean,
But
it is what it is. I'm not going to,
yeah.
howl at the moon. The other thing is for entrepreneurs, don't spend your time convincing people to invest in your company.
Hmm.
Spend your time finding the people that want to invest in your company,
That
uh,
believe in your technology.
that,
Yeah,
that
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 believe in you.
understand the problem,
Yeah,
that understand the value proposition you're offering. When people say, I'm not interested, it's not going to work for these reasons, say, thank you for the quick
right.
decision and go spend your time finding somebody else. You don't have to convince them.
Hmm.
That's not your job. Your job is to go out and find people who share your vision, who can add value to your company. You don't have to be right. You have to be persistent and always looking for that next opportunity.
Right. And I think that's good advice. I mean, with employees, whether you're seeking any kind of partner with business, whether you're seeking clients or investors or any other kind of shareholder, is looking for people who have alignment, who believe in your vision, who believe in your technology. Like you said, you don't want to have to convince people because then it's a never ending effort. So, you know,
There are times where you're in the middle of a close and they're interested and they're just throwing up questions to see how you react, or they need to be convinced themselves, and that's when you use the disqualification clause when they're
uh-huh.
closed, and you just simply say, "You're right. This investment isn't for you." And you repeat back what they said. It's too risky for you. The timelines are too long. We're not focused. You're right. All that. I'll give you all that. Have a nice day. And then they turn around and go, "Oh, no, 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 wait, 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 wait. No, I really don't mean those things. No, I think you've really got it." And then they talk themselves into it. So there,
Ah.
there are times to use the disqualification clause. But that only comes to experience, knowing when to use what technique with investors and
Right.
such.
Right. Yeah, sometimes they're just double or checking, I guess just
Yeah.
yeah. And
And
it's not
and
yeah.
now and nowadays the other really amazing thing, old man talking here. We were told 30 years ago, only talk to 10, maybe at the most 20 different people to get investments, the venture capital groups and so on. Nowadays, if you're not using PitchBook or Traxon or one of these huge databases out there, and you're not approaching thousands of people looking for money, you're not doing it right. The AI tools, these huge databases, and just the explosion of high net worth individuals, explosion of wealth,
Mm.
the explosion of investment capital. 90% of companies fail, and people are still throwing money into this sector. If this was a business school case and you didn't talk about that it's venture capital, or something, you said, "Oh yeah, 90% of your investments will fail," people would look at you like, "Why are you in that business? It just doesn't make any sense." But fortunately, because of the amount of wealth and we've got a nation of entrepreneurs, this system still works. And there's more and more wealth out there. I was in Texas 2 weeks ago. I was in South Florida last week. Just the pockets of smart investors that are out there now looking for early stage companies is remarkable. It's fantastic. And you just have to get out there and refine your story, make your business good. It's not all about the pitch deck. It's about a good business. You can find people out there. It's really amazing.
Right. So there's a lot more opportunity I'm hearing, but you have to approach a lot more people. You have to get out there more and maybe more competition as well, just more people
I don't
trying.
see it as competition. It's matchmaking. It really is
Mhm.
matchmaking. It's finding people. There are people out there that only want to do fintech. There are people
Mhm.
out there that only want to do software. That's what they do. We're in a peculiar space. We're material science
Yeah.
in this company. This is not generally a venture capital business, and we can't really position it as material science. Some days I position it as dual use technology, military and civilian. There's several new funds out there in that area we're talking to, as well as people that have come out of the military, high net worth individuals. Sometimes we're positioned as biomedical, because we have a lot of biomedical applications. So it's finding where you resonate with that investor.
Right. Yeah, that makes sense. Now, you've said technology selection is the step few teams ever undertake, yet it's the most important one. Walk us through your framework. What are the criteria that determine whether something is a business and not just a science project?
Okay, so if you go to wardenchem.com, you'll see all of our criteria there. And we looked at 800 different technologies, and we had 10 criteria it had to fit. I don't know that I'll remember them all now, but things like, does it fill an unmet need? And it's just not now, but also looking forward in the future. Does it fit a fundamental unmet need? Would this business scale? Does the professor have a prototype? We needed to see prototypes to actually see that the stuff worked. Can you manufacture it at the right price? Does it have strong intellectual property? I want an unfair advantage. I do not want to compete on trade secret or on price. I want very strong IP with a long lifetime ahead. Can I get all the rights that I need of that IP? Do you know the exit before you start? So have you talked to people that might buy your company? And then, is the professor insane? Is one of my things, because, or
Right.
I should probably add to that. Do they have the potential to go insane? So we show up in person, we talk to people, we break bread with them, we meet, if we can, we'll even meet their families and friends. because you're going to be doing business with this person a long time. And if they go nuts, and we've had 3 or 4 deals go south because people have gotten greedy at the closing. They have delusions of grandeur. They don't understand the amount of work that's involved, even though you've tried to educate them through that. And that can really blow up a lot of things. So you want to determine that early. And you have to look at a lot of technologies. Oh, do we have the expertise to run this company too?
Mm-hmm.
Do we have the expertise, or can we gather the expertise, compete for the expertise to make this business successful? So we look at it from the exit to the operation, going backwards to sales, operations, and all the way down to IP and founders.
Right.
We're working all the way backwards through all of those to make sure we've got a winning team. And even then, it's going to be hard.
Mm-hmm. No guarantees. It's still risky. Yeah.
But it'll give you a better chance, because there are a lot of things that are outside your control. But you'll dodge a lot of the pitfalls, founding pitfalls. You'll dodge the middle stage pitfalls of IP, and then you'll dodge maybe the end pitfalls that you don't have an exit, right?
Mm-hmm.
So you're trying to avoid that. Any one of those at any time, could blow you up. So you're trying to identify what those might be, and then you want to make sure that you actually have something that people want to buy, obviously.
Right. So. And you and your team systematically reviewed 800 technologies, narrowed to 40, optioned a dozen, and spent 18 months de-risking before choosing a few to launch. What did that process reveal about how universities and founders misjudge market readiness and commercialization timeliness?
Well, I don't think they misjudge it. I think they know that they don't know. The university tech transfer offices have gotten really sophisticated, and they know that they don't know. They want to understand more about the opportunity, the market opportunities for these technologies. You got to remember these tech at the bigger schools, these tech transfer officers are seeing hundreds of technologies a year. They've got a small budget about how to parse it out. Sometimes they parse out their patent budget to keep a professor. I call some of these offices are faculty retention offices. They're there to keep the faculty happy, not necessarily to license technologies.
Right.
And one of the ways we got the options, we would get options for free. We actually didn't pay for the option. We would tell the university, we're going to spend 3, 4, 5 months doing a market study. We're going to write a business plan for this, or the beginnings of a business plan. And if at some point we say it's no longer good for us, we will hand you the report and we will walk away. So, we're doing $30,000, $40,000 worth of market research and study and business planning. And if we walk away, we hand that to them, and they then can see the entire opportunity laid out by an entrepreneur. They're getting a business plan. And they really like that idea, because maybe they can parse that out and then use that to sell their technology to somebody else. So we were generous. They would give us an option. So when we spent the work, we know that it wouldn't go off to somebody else. And at the end, if we didn't pursue it, they got something for that. They got something in return. And that was a good deal for both parties. So I think university tech transfer offices are pretty sophisticated. They have realistic views of what deals need to look like. Now, there are exceptions to that, but they've really evolved to be pretty professional. Occasionally, they might be unrealistic. And then, if you can't do a good deal, you walk away. There are other things to do.
Right.
Right. The professors, on the other hand, they're completely out of their skulls. They heard about somebody who got rich off of technology, and they think theirs is, really big. And
right.
They didn't understand. All they heard was so-and-so got rich off the technology, right? And they didn't understand what that might have entailed, or the 95 others that didn't make it, and that's the one that did. So they immediately think that they'll do the same. So there's a wide range of professor mindsets that are out there. They're not as necessarily as sophisticated as the tech transfer offices. Yeah. Tech transfer offices, that's all they do all day. Professors are in their lab trying to keep their lab going and trying to write grants and get more money for their labs. But you find the right professor, you find a good one. Our guy's fantastic, John Welker. He's fantastic. love working with them. But we've had others we've run into, and we've walked away from deals because the professors went nuts.
Right. No, like you said, that human factor that you don't expect will be an issue comes up because of, different, they get greedy or they get unrealistic about what,
Yeah, I think
yeah.
it's unrealistic. The greediness is secondary. They're unrealistic. And the other thing is you got to show up with these tech transfer offices. You've got to sit in the room. You've got to go into the professor's labs and talk to them. Everybody's trying to do things over like we are, video conference. And no, you got to show up. One of the reasons we got deals done is we were in the labs. Those technologies have been sitting there for a while and nobody touched them. And, one time we asked one university office, hey, why do we get this? And they said, you're the only people that showed up.
Really?
Yeah. Everybody else tried to do it on the phone. They never met
Yeah.
the professor. They never went into the labs. We took 2 or 3 trips out there.
Yeah.
You got to remember, you're going to spend 5 years of your life and 5, 7 years away from your family. You got to really spend a lot of time choosing right.
Mm-hmm.
It sucks to close a company. I've done it once. It sucks. It's painful. It's a death.
Right.
You grieve. It takes a long time to recover. It's hard.
Yeah.
So you should be spending a lot of time in making that decision because it's the next 5 years of your life.
Right.
And the other thing I was going to mention is the tech transfer offices are funny because you go in. We went into one university. There were 4 or 5 technologies we were interested in, and we put the technology disclosures on the table. You said, we're interested in these 4 or 5. And you said, which of the professors are crazy? And they laughed, and they just take two of the 5. They just said, yeah, don't even bother. They knew exactly what we were asking, and they knew exactly the risk we were talking about. They know.
Wow.
Yeah. And so we didn't even bother looking at those.
Yeah. So Muscle Polymers started with a Navy-funded Purdue technology originally aimed at underwater bonding for submarines, and you've now identified a massive range of applications. What was this is the one moment that convinced you that this polymer platform could be as big as Teflon or Gore-Tex?
Yeah, that's a good question. So it was something that my business partner, he's our chief science officer, Eric Anderson, and he just, devours technical material, patents and scientific papers like, very few other people can. And as we began to dive into our class of chemistry, catechol chemistry, he began to read some of the literature around that during our due diligence. And then we began to realize, or he began to, tell me, I just read an article that says catechol polymers can grow bone on implants. And I'm like, yeah, right, Eric, we know that 35% of scientific literature is can't be reproduced. That's a nice way of putting it. And I said, if that's the case, we hit the lottery, but let's not look at that later. We're only focused on this. And then he said, oh, there's this and there's this. And then we began to realize that there was a class of chemistry out there that this applied to. And then we found, not one article that we could grow bone on implants, but 5 or 10 or 15. And now you're beginning to, oh, it's reproducible.
Right.
So it was, it came along. That was pre-AI. Now we probably would have known that in the first hour of research. We wouldn't have known that now. It wouldn't have taken so long. So yeah, I remember the first time telling him, yeah, whatever. That's not true. That's just ridiculous. Nothing does that. And then, 3 months later, it was like, he goes, wait a second, there's something here. And that was sort of an aha moment for us. That's a two-edged sword because it's a distraction from, you got to focus, but, you want to diversify to reduce your risk. That and knowing how many potential applications there were for our technology, we had to devise a business plan, an operation plan, unlike pretty much any other business I've ever been involved with or I've ever heard of.
Right.
These technology platforms like this, these material platforms come along once every generation. They're very rare. So when you get a hold of one, it's challenging. Has its own set of challenges.
Yeah, absolutely. I mean, with so many opportunities for applications, I mean, how do you decide what to focus on first and how to direct that business plan?
Yeah, there's a little bit of figure it out as you go because you're learning so much stuff in your technology development. You're always adjusting your strategy. But first things first was make it reproducible at scale. that's what we spent a lot of our time on, because we had to go down that route so we'd have a business. And then at the same time, we were evaluating literally hundreds, if not thousands, of applications. And we would pick an area, and then we had a set of criteria of things like, there was a scoring done of things like, how long will it take us to make it? What are our margins going to look like? Is there an exit in this area? Because each application is basically its own business.
Right.
Yeah.
Yeah.
Right. Can we get a partner? What are the regulatory hurdles? What are the other hurdles to get to market? Are we displacing another technology? So we really focused on here. We focused on the highest impact areas where the next best alternative really didn't exist. There really was no solution to the problem, and that had low volumes of material.
Mm-hmm.
Right. And where people would write checks. Those are the three biggest ones. Right.
Yeah.
Low volume, high margin is biomedical. But
Mm-hmm.
the challenge there is long regulatory timelines. However, the mouth is a separate place than the rest of the body. The FDA has very much shorter timelines for medical devices in the mouth. You can get stuff through there in a year. So we start with the low regulatory hurdles, low volume, high margin, solve a problem nobody else can. That's where we went in biomedical. We kept the military because the military was funding. They have an unmet need. There is no underwater adhesive. There's no mil spec for an underwater adhesive. It doesn't exist because there are no underwater adhesives that works. There's no mil spec for it. So, we're solving a problem that no one's been able to solve before. And somebody's writing checks to do that. So we'll focus on that one as well. So that's sort of the process we went through.
Yeah, right. Yeah, like you said, they're entirely different businesses, and so different verticals that you can enter and approach, and so just developing criteria around where to focus your efforts and what's going to be commercially viable.
And I think investors, because you're always thinking about how investors are going to take this, we had to refine the story so it didn't look like we were not focused. Investors are used to one-trick ponies, right? You do one thing, you get your minimally viable product, you work on your product, you work on your product market fit, and you just go, and you go down this line. We have things that can do 100 different things. And what I tried to do was position it, look, this is a strength.
Mm-hmm.
You're one of the reasons all these companies fail is they do one thing. And if it doesn't work or somebody comes in and outcompetes them, that's really hard for them to recover from, right? Yeah, if they cut off, if the military said, hey, we're not going forward, well, we got a biomedical application, we've got a civilian application, a cosmetic application. We could just pivot, the same knowledge, the same manufacturing, the same low-cost manufacturing, at scale manufacturing can be applied to these 4 other industries. So none of your dollars are wasted. We're still capable after going all these other industries, even if one gets blocked out. Diversification is important. Everybody's plan fails at some point, and you've got to be able to adapt. Ours had built-in adaptability.
Yeah. So for our listeners who aren't familiar with Muscle Polymers, tell us a little bit about your technology.
Oh, sure. So there's a fundamental problem with materials. They don't stick when wet. You can't paint a house when it's raining outside. You can't glue things together underwater. But it turns out blue mussels figured out how to do that a million years ago. They stick out their foot, the mollusk. It sticks out its foot underwater, and it secretes a glue that cures instantly underwater. And a professor at Purdue looked at that mussel foot protein, which is a very large molecule, and he found one very specific part of it that actually did the gluing. And he made a 100% synthetic version of that glue. And that wet bonding adhesive can be used to glue tiles to the outside of submarines that defeat sonar. The tiles defeat sonar. And that is something, stealth for the Navy is very important. And it's been a pressing issue for them for some time. So that's one area. But there are really no adhesive approved for inside the human body. This material can actually glue through blood. Wow. It can glue to all sorts of different tissues. And the human body is a very wet place. And dental adhesives, we all know, fail miserably. I mean, if you have a cap, it pops off every 2 to 3 years. It's an annuity for the dentist because they use adhesives that, by design, essentially fail. They absorb water and they fail. Ours lasts 5 times longer in the mouth, independently verified. So just like Teflon was super slippery and nothing stuck to Teflon, ours is super sticky and it sticks to everything. It sticks to metals. It sticks to wood. It sticks to biological tissues. It sticks to plastics. We can glue Teflon together. So Teflon's super slippery. Ours is super sticky,
Mm-hmm.
and super sticky substances have a lot of use in the world. And
Yeah.
that's sort of we're a polymer, and we can make it at scale. And that's sort of what our business is. We figured out how to make it at scale at the right price, and now we've proven out a whole bunch of verticals that we can go after and products we can go after.
Right. So now it's just like, yeah, where to focus on or what to focus on first, and where to take it so it's most profitable or useful.
It's the challenge of our business now is, you learn something in every business. My first business, I learned the sales cycle is something you've got to understand. And my first business failed because the sales cycle was too long, and the professors went insane. It was a good combination there. And for an entrepreneur, you can't have a 5-year sales cycle.
Mm-hmm.
You've got to get to revenue a little bit faster than that. In this business, what we learned was we can make products and we can test them quickly, and we can show, hey, this works. The qualification for some of these products can take 3, 4, 5, 7 years. Not regulatory, just qualifying the product, all the
Right.
tests. They don't have accelerated aging tests in some of these industries. So they put something in a spray chamber and they leave it there for 4 or 5 years to see if it lasts,
Yeah.
So you sit there and you twiddle your thumbs. Well, we don't twiddle our thumbs. We're going after 7 other different applications while they're doing that. But that's the challenge that I don't think we fully appreciated when we started the company. But that's why we have near-term, medium-term, and long-term products. We have a nice mix in our products.
Like you mentioned, diversity.
Diversification in terms of regulatory risk, diversification in terms of adoption risk, diversification in terms, it's all sorts of market risk, price points, everything.
Now, you've drawn a sharp distinction between biomimicry as inspiration versus biomimicry as a business thesis. How do you tell that story so it's compelling, but still grounded in real commercialization and not just a beautiful narrative?
Well, yeah, I like biomimicry. We have a nice prize here for biomimicry. We were selected a Ray of Hope Prize in 2021. Biomimicry is a great place to get inspiration to solve problems. It's not a business model. People, I'm really excited by biomimicry. I want to do biomimicry. There is no business in biomimicry. People are out there to solve problems. Go look to nature as one possible place to find something to solve a problem. But take a chemical system out of nature and reproduce it and take it to scale, that's going to take a decade. It's a long time. Physical things out of nature might go a little bit faster. I get a lot of notes from college students. I want to go into biomimicry. I don't understand what that means. You want to be an evolutionary biologist? Okay, be an evolutionary biologist. But as business, it's just a place to go look. Like there are 100 other places to look. It's not a business model.
Yeah, it's a resource. It's an opportunity for a possible place for solutions. But yeah,
right. But there are investors that might want to invest in biomimicry. So you might find them. There are probably a couple dozen out there that I'm looking for biomimicry companies. They're not looking for businesses that'll be successful. They're just fascinated by biomimicry and they want to invest in that area. I don't think that's really an investment area. It's not a business.
You've achieved something founders dream about. You moved from a lab scale material that was effectively impossible economically to something manufacturable, dropping costs dramatically and scaling production. What were the key technical and operational unlocks that made stable, scalable catechol polymers commercially viable?
Well, during our due diligence, we saw how the professor made it. It was patented. To his credit, Professor Wilker made something that no one had ever made before. He made a biomimetic. He found this. First off, he had to figure out what to copy. And then he wanted to make one of them. He was not interested in making an industrial version. So he's a good chemist, and he figured out how to take a series of chemical reactions and make what he wanted. But he never did it with the mindset of, I want to make tons of this stuff. And that's the way most professors work. They want to make one and they're going to go do the next thing. So when we saw this process, it was a little finicky. It was a little touchy at certain spots. We got some, chemical engineers to go look at this process, and they said, "Oh, we can do this way. We can do this way. We can do this way. We can eliminate those steps entirely." And so they looked at it, and they said, "Yes, this will scale, and these are the steps we're going to eliminate." So the trick was, I think he did a 6 or 8 step process. We got it down, and one of the steps was at minus 20 centigrade. And we got it to a 3-step process that you do at room temperature. So you eliminate steps and you do it all at room temperature. And we figured out some ways to save reagents, certain reaction steps. We made some of the reaction steps more efficient. And we're constantly refining the process. Not too much, because our margins are so high. It's not a problem you need to solve now. We shouldn't be driving the price down another 10% when our margins are already 90%. It doesn't really, you get to 91%. Well, it really doesn't matter. Spend your time, proving out new applications. So, it was really reducing the number of steps, increasing the efficiency of the steps, making them happen at room temperature. Now, those are sort of the standards for making chemical processes work more efficiently. The other thing is we really wanted to use standard unit processes. So every time we removed a step, we didn't want to have any special equipment. We wanted to use equipment that people use in current chemical plants. And we've been very successful at that. We have really good chemical engineers to do that.
Right. Yeah. Now, George, you're working on a book about this entire process because you believe 90 to 95% of university startups shouldn't exist as companies. If you could change one thing about how innovation ecosystems work, what would it be?
Well, I'd have them read my book once it's done.
Well, tell us a little bit about it.
Yeah. I think it's that working backwards approach, is having realistic expectations of what it takes to be a business, not be a product. There are a lot of companies don't fail because people don't raise money, and companies don't fail necessarily because people don't work hard. People work hard, they raise money, they make products, they get sales, but they don't get enough of it. It's really having the entrepreneur focus on the business aspect at the end, and start at the end and work backwards is what I'd say. Really, if all of the stuff that's in your, right in your windshield right now, assume you will solve all of those problems. Start there and then figure out whether or not you have a business. And people are always focused on the stuff that's right in front of them, obviously, because that's what they have to get done. But those aren't the things that are necessarily going to decide whether or not you have a business or not. I'd really have them assume everything you think you can do technically. Mm-hmm. Assume you can make the product you think you can make, and then make it 50% better. Start there, and then start your study of your opportunity at that point, right, and see whether or not you've got a business. That's not where their expertise lies. That's not where their experience lies. That's not why they're getting into the business most of the time. They're getting into the business because they learned the technology. And they don't look much beyond the first one that they make. And they think everybody wants it. And it's much more start at the point where every single technical challenge is complete. You can make it at the right price. You can make it at scale. Now, do you have a business in 5 years? And I don't know that all of them know how to evaluate whether or not they have a business.
So, you're right. So is that what your book will help with? Is that evaluation process?
Yeah, absolutely. That's exactly what it's about. It's going through those 10 steps. I'm going to have some call outs called George's Rants. I think there'll be some in there where I bark at certain sectors of the economy and the ecosystem. But yeah, I think that it gives them a perspective of the business challenges. Don't look at your technology as just one tiny part in this. You're creating a business. You're not creating a product. Creating a product is not creating a business. Creating a widget is not creating a business. You really have to look at what the business challenges are. And yeah, that's what I'd like to get them to look at. And I'd like the investors to look at it too. Why should angel investors be losing at the rate they are, right? I had some very experienced West Coast investors, and this was amazing to me. I think it was 3 of them that I spoke to. I didn't tell them what the technology was we had selected. I just told them about the process. I said, we had these 10 criteria. These were the criteria and why we had them. We looked at 800 technologies, reduced it to 40, reduced it to 12, de-risked them over the course of 18 months. 3 of them said, I'm in, I'm investing. I said, I didn't tell you what the product is yet. And they said, it doesn't matter because nobody does what you did.
Right.
You know,
Yeah.
that's what we do when we get 100 different things. We have to go through that process for each company that comes to us. You already did it
Yeah.
and you picked the best one. Nobody has that kind of rigor or that kind of process. So what am I going to tell you you're wrong? Because I'm going to do the same thing. You
Hmm.
did it already. And they literally wrote checks and they said, okay, now tell me what the business is. And I told them, and I'm
Wow.
like, cool. All right. But at the same time, that's the way the system works right now.
Hmm.
People get excited by technologies and that moves them forward. And look, technology development is not a straight line. There's all sorts of excitement, randomness, luck that sways the trials and tribulations and pathways of new companies. I don't want to discourage inventors. Inventors are always going to invent. That's the one
Right.
type of entrepreneur. But people that want to run tech businesses and are excited by technologies, and you've got a skill set to run a company, go out there and find the best opportunity. When you're
Hmm.
an investor, go out there and find the best company, not the best technology. And that's sort of what I want to get is there's a generation now of experienced entrepreneurs, and they've got a skill set that can translate from technology to technology, from industry to industry. And this is an opportunity now for experienced entrepreneurs to go find really cool technologies. The technologists don't have to start the companies. The entrepreneurs, experienced entrepreneurs, can find the best opportunities and seize them and run with them. So it's a real switch, potential switch in the ecosystem now.
Right.
And imagine even if we doubled the success rate from 10% to 20%, how amazing that would be. It changes the economy. It really would. So I think it's important. I think it's just such an exciting time with AI, how much more efficient we can be with AI. I used to get paid to write business plans, and I'd say, how long would it take me to write the business plan? I'd say, it's going to take me about 8 to 10 weeks to write a good business plan for you. Now with AI, I write internal business plans in an afternoon,
Hmm.
and they're better than what I did in 10 weeks before. It's
Same.
stunning.
Yeah.
And so that really gives you the opportunity. There's no excuse not to do that kind of homework before you start a company because you can get it done in an hour or
Right.
2 or 3 hours. Now, your experience, you have to have experience, but you can talk to so many people now. The systems are so powerful. The system should be more efficient.
I totally get it. So your book is basically your playbook for evaluating opportunities that will guide investors or people considering starting a business on
Yeah, I
how.
think it's for entrepreneurs, tech transfer offices, investors of all ilks, angels, offices, venture capital. Uh, look, there are a lot of good business books out there. This will be, hopefully one of many, but there's some really good ones out there. Everybody's got their perspective. One short, sweet, pithy, hopefully entertaining, bit irreverent. That's what I'm sort of trying to figure out.
Well, we'll keep an eye out for it. So, for leaders listening, manufacturing execs, corporate innovation teams, investors who want to partner with universities or source new technologies, what are the three practical questions they should ask to avoid funding science projects and instead back real businesses?
When you're working with universities, the university is going to want you to fund a science project. So you know that going in. You have to know the laws and specific rules about working with not-for-profits like universities, and you have to have realistic expectations going in. So that's one big thing. The universities want to publish, and you might not want them to publish, so you have to understand how to, walk that fine line between getting the IP protected and the professor being able to publish about it. You have to understand who's going to own the IP. So I think you really have to understand the IP and the disclosure requirements. That's a big one. And then you have to know exactly at what point you're going to take it and what your plans are for it. You have the very specific endpoint of what you're looking for. That line between basic research and applied research and what they call translational research. Some universities have specific funds for that, and it's best to go with an experienced university that's done it before, that has translational component to their program. I think they're good places to go for that. And if you're going to put up your money, it's not going to look like any other contract you've done. It's going to be different. And you have to have realistic expectations on your timelines. When you put people on a project in your corporation, that's all they do. You know, the professor and his lab have got 10 projects. Not all of them are funded. They're trying to get funding. They're trying to write papers. They're teaching. They've got graduate students. They've got obligations to the university to sit on committees. The pace of innovation is slow. They don't work to a goal. They're following their nose. You know, they're looking for exciting discoveries on something they can publish, and that continues to make them a thought leader in their world. And they're not going to work like you work. And then for from the university side, I don't think universities fully appreciate the professors don't always appreciate the timelines and the accountability that lies on the corporate side. There's real accountability there. There's timelines. There are results, and they happen quickly. And so they're not going to understand necessarily what you do unless they've done it before. Yeah. So that's the other side of the coin. I don't think that, maybe not so much the problem now, but if a professor's working for the first time with a corporation, I don't think professors fully appreciate how smart the people are on the corporate side, technically and business wise, and how many resources they've got. Professors are the best in the world at what they do. And they think that, because they're the best in the world, nobody can be the best in the world, right? And they don't realize just how smart the people on the, in the corporate world, and just how much they get done. And they don't really understand the challenges that it takes to get a product to market, to build a business. They just say it's a black box to them. Their technology comes in and the company's making billions of dollars. They think it was all because of what went in, right? Not what went on in the black box. They just saw that their technology went in one end of the black box and the corporation's making a lot of money on the other end. And that black box had nothing to do with what came out the other end. And that's where most of what occurred happened.
Yeah. Where the misunderstandings and all that, they don't see everything else that happens. Now, I guess my final question is, how should an entrepreneur or corporation decide whether to partner with the university and professors versus bring R&D in-house or work with like a separate R&D firm?
Yeah, so what professors generally have is their goal is to be the best in the world in a very narrow area. And if you need that very narrow specific area, and that's the only place you can get it, that's why you go partner with that professor. If they have strong IP, if they have knowledge, if they have capabilities in instrumentation and tools in their lab that nobody else in the world has, then you go partner with them. It's the only place you can get it. That's what you're looking for, is that unique quality, that unique skill set, the unique knowledge set they have. If you can get that anywhere else, you should be working with that professor, right? You're going there for that very specific knowledge-based skill set that nobody else in the world can do. And that's why you go there.
Awesome. Well, George, thank you for joining me. I love how you bring both rigor and realism to innovation, because you're not just celebrating technology, you're talking about the hard truth. Because commercialization, like you said, it's a discipline, and building a company starts long before the product exists. It starts with selecting the right technology and proving it can become a business. Now, for listeners who want to learn more about Muscle Polymers, how can they reach out?
Oh, they can reach out. I think it's info@Muscle Polymers, or I think it's Let's Bond at musclepolymers.com. You can email us there. Go to our website at www.musclepolymers.com. We also have a product called CTAC. You can go to ctac.com. Reach out through LinkedIn, however you like. If you have any interesting technologies we should take a look at, send them our way.
Excellent. And what about your book? What's the timeline on, or do you have a timeline on publication?
I've got a company. Running this company keeps getting in the way of finishing the book. But I in my last 3 months, it's really come to the fore. So I'm going to try to finish it here in the next. Well, I'd like to get it done by the end of the year. I've got a pretty good start, but
keep me posted.
I will. The working title of the book is "Your Baby Is Ugly."
Yes, I love that.
Yeah, so we'll see whether or not that continues through. I think it will. I'm really excited about it. But the most important thing is get Muscle Polymers going, get us to exits here in the next 24 to 36 months, get my employees in really good shape, get a return for the investors, get a return for myself and my team, and get these products out there where they're helping people. And we're right at that point now. We're bringing out a whole bunch of products. Really excited about it. It's a really good time
Yes.
to be out there.
Very exciting. Yeah. Please keep me posted. And yeah, I'm excited for you.
Okay, stay in
All
touch.
right.
Thanks, Leanne.
Thank you. And for our listeners, if you enjoyed this episode, subscribe to Industry Ignited and tune into the next episode, because these conversations are about what it really takes to move innovation from lab benches to real world impact. Until next time, stay bold, stay curious, and keep igniting industry.